And as the film progresses, he starts to change his behavior. And he's sweeping through all of the possible behaviors he can do, and he finally finds that one perfect day that lets him escape. And the key for him to escape is that he begins to learn and understand his positioning in the network of social connections he forges in Puxatawny. He goes from being a complete and utter outsider to being the one person in the center of all of the different social worlds that exist in Puxatawny. And he is able to use that information to save the life of the one fellow who collapses on the street, to bring other people together. You could do worse than watch Groundhog Day for an introduction to agent modeling. At its core, Groundhog Day is an agent-based model, and it's focusing on a single agent. I really like Groundhog Day. So, in an agent-based model, you're not creating the one perfect equation that specifies everything. There is no E equals MC squared. But what you're doing instead is you're admitting, yeah, there is complexity, and I have no idea how it all works. But what you can do, and what the constriction, the straitjacket of an agent-based model is you can describe the behavior for a single individual. You can state, okay, this is what an individual will do. But then you give that individual a whole range of variables. Everybody in this room, I'm sure, has a political orientation. Some people will be conservative, some people will be liberal, some people NDP, some people will be green, whatever. One variable, political orientation, but with a distribution of different views. Same idea in the agent model. When you take that single agent and you multiply him 100 times, or 1,000 times, or 1,000,000 times, the interaction of the rules with the agent's own individual characteristics can lead to surprising behaviors. And in fact, that's where you'll get the goldfish jumping out of the bowl. You know, this goldfish is a dreamer and wants to go somewhere more with his life, so he's able to jump out. It was the best illustration I could find. I'm trying here. So, behavior in an agent-based model depends on the unique combination of characteristics that each agent has and the way that they come together. So agent-based models are contingent and they have history to them. And the behavior can also be contingent not just on the interactions between individual agents, but also with the environment. So that's a potted version of what agent-based models are about. And I've suggested that the role of simulation is to come to grips with complexity, but there's also, you can cut that in 3 more ways. You can be using simulation to generate hypotheses when the thing that you're trying to study you don't really know much about, but you think it works this way, you build the model, and it helps clarify your thinking in that direction. Or maybe you have a pretty good idea of what it is you're trying to study and you want to zoom in and focus on particular aspects of it. Simulation is acting like a microscope in that case. And then maybe you really understand the dynamics that you're trying to look at and you want to predict what will happen. There are some amazing models that are based on trying to understand how people leave a building. Okay, you leave a building, some people will stand aside, some people will hold the door, other people will come through with their elbows. To create a model like that, then they can use that to test flow patterns in sports stadiums, movie theaters. You can say, okay, what will happen? Where will the choke points be if there's a fire in this theater? So that's an agent-based model being used in terms of simulation. The way I've been using models is more somewhere between the generating of hypotheses and the mediator, the microscope. And I'm going to be showing you 2 models, one that's already been published, one that God willing, will eventually come out this year. Well, there's not much time left for this year. So I mentioned that the models can be interacting with their environment. And this is historical uses of GIS are great for working out patterns. You can take those patterns from the GIS, put some artificial agents on top of that, and start seeing how the patterns could be generated. This is a distribution map of geometric sites from mostly Attica, the Corinthia. So we're in Greece here, we're in early Iron Age Greece. And I completely forgot where I was going with that thought. It happens sometimes. Yes, the idea here in this model was I've got a map with real world data on it. I want to know how territories emerge from this map. So I created a model where the basic idea is you only really want to go someplace if other people are going there as well. That's the kernel of the entire model. This is the Traveler Sim model. It's the full text of that article is on my research blog, so there's more information there if you're interested. But that's one example of an agent model interacting with a real physical world. The program that I use, the environment that I'm using for my agent modeling is called NetLogo. And the wonderful thing about NetLogo was that it was developed to help teach high school kids how to deal with complex systems. That means the rest of us stand a chance of understanding how to use the program. It works by programming in near English. So instead of the, you know when a website crashes and you see all the stuff and you go, what the hang is that? It's not like that. It's actually much more, I don't even know what the word is, but it's accessible. And when I started working on this in agent modeling in general, 3 hours with the tutorials that came with the program, and I was starting to build little wee basic models. After about a week, some really interesting things were starting to happen. So NetLogo is a really wonderful tool for anybody who's interested in this approach, this methodology. And NetLogo lets you have agents, these independent computing objects moving around through space, on top of what is essentially a checkerboard. Each pixel in that screen is another computing object. It can keep track of agents on top of it. It can, say you were interested in how wolves eat sheep and sheep eat grass. Well, the wolves and the sheep are obviously going to be moving around. The background can be growing grass to eat after the sheep go by. Wolves and sheep could be fun. Or it can just be simply background. There are models that work that don't use the background for anything other than a pretty picture. So, if I'm making any sense at all, I'm hoping that you're seeing that agent modeling can get really complex, but it can also be quite complicated. It can break down. Sometimes you have to sit and you have to do, like any piece of computer work, you have to find the bugs and fix them. So I want to take you now to what is in essence a really simple model, but it let me start doing some, well, what I thought were quite interesting things. And the simple model was the one that was published in the Antonine, or in the Journal of Mediterranean Archaeology, about the Antonine itineraries. Have you heard the news? Did you ever play that game when you're a kid where you all have to, you have a message and you tell the next person tells the next person, and by the time it comes through over here, the I have a loaf of bread becomes, give me the keys to your car. You know, it transforms like that. In essence, this model isn't more complex than that. In antiquity, in Roman antiquity, travel times and connectivity, getting around that big donut of the Mediterranean was difficult. And it plays a role in politics and economics and in the degree to which different areas become Romanized. Romanization is an awkward term, but if it means anything at all, or if it means the degree that conquered people subscribe to a Roman worldview, then, and this is something that gets Roman historians quite excited sometimes. Ooh, Romanization, let's talk about Romanization. Or at least it did about 5 years ago, maybe I'm out of date now. But the question that needs to be asked, well, how does information move in that world? How does it get from this side of the room to that side of the room? How does it get from this side of the empire to that side of the empire? And what kind of transformations does it go through to get there?